Voice of Industry.
Voice of Industries.
Manis, welcome to Voice of Industries. I'm pleased to have you here today to discuss about your experience with online analysis in industrial processes. Could you introduce yourself and your role at Axel'One?
Yes, so hello Mathieu, and thank you for letting me the opportunity to do this podcast. So I'm Manis Gheghiani, I'm a PhD in process engineering. So I did a lot of work on monitoring of polymerization, which includes online analysis, data treatment, and also fusion of data. From 3 years now, I have started to work at Axel'One, and I'm managing the spectroscopy, data treatment, and digitalization part inside Axel'One.
Manis, could you explain a bit more what is Axel'One and how it is born?
So Axel'One is a collaborative platform, and we have a strong activity for the process industry. So we have a consortium that include a lot of industrial in the field of chemistry, polymer, petrochemistry, pharmaceutical, and we try to answer their need in the part of industrial analysis. So this can include every aspect. So it can be sampling, it can be choice of technology, it can be some bibliography also, and it can be also some data treatment. But I will go later into the details about how Axel'One is working. And so the main part of our activity is to work with this consortium. Our activity is not only for the consortium of industrial we have, we can also extend our activity to every company. We can help every company to get the best choice of technology because we have a lot of equipment in our lab. So our offer service can be used by the companies to do fast tests so that they can answer their need quickly without doing big investments because we have every equipment inside our facilities.
Okay, first, could you explain what online analysis is and how industrials can use it?
So first you have to know that there are different kinds of analysis. So the classical way to do analysis is to do it offline, which means inside the process some samples are taken and then the analysis is doing afterwards. With online analysis, we try to implement the analysis inside the process. So it can be done in different ways. You can include directly the analyzer inside the process, or you can either work by doing sampling loop so that you can conduct the process directly inside the analyzer. And this allows to do online measurement. So you have data in real time, you have in process condition, so you have representative analysis, and you can better understand the process. And so the industrial usually use it to monitor the process in real time in case they have any issue of safety, in case they have any deviation about the quality of the product, or in a different way in order to guarantee the better condition to run the process.
In my experience, online analysis isn't yet widespread within the industry. Why is this the case?
Online analysis is not so well known because most of the time people, as I said before, work with offline analysis to do the characterization. The issue with online analysis is that you need to have a lot of skills in different areas. So you need to know how to do the sampling, so how to conduct the process inside the analyzer or how to implement the analyzer. You also need to have some skill about which analyzer to choose. So you need this kind of competence. And another part is also the data treatment, which can be quite consequent. And this is also another part that you need to know. And so this is because you have different field of skills that it is complicated to be implemented inside the industry.
I can also imagine that in the laboratory, you have very nice condition, it's clean, etc. But when you want to implement a very sensitive analyzer inside the plant, the conditions are not as clean as you have in the lab. So you have to have the proper design of online analyzer to stand with the harsh condition of a plant.
Yes. In fact, when we are doing analysis in the lab, we need first to think how can we implement this analyzer inside the plant or inside the industrial site. Because this is quite important because if the lab is working well and in the production plant it's not working, this is not sufficient to implement the analyzer and to choose this analyzer. So this is one of the characteristics to choose the analyzer.
Having said that, how do you assist industrials in implementing this kind of systems?
So we have developed a methodology to help the industry to implement these systems. So first what we do is a proof of concept. So we try to have some samples to work offline. And then inside the lab, we do some analysis to choose the right technology to implement. After that, we try to work on the sampling system inside our lab. So we try to replicate the condition inside the industrial site in our lab so that we are sure that the analyzer fit with the industrial condition. And after that, we do some experiments directly inside the industrial process so that we can be sure that the analyzer is fitting the requirement of the industrial.
Does that mean that you can provide industrial with some kind of mobile analyzer that you can bring on site and test in real conditions?
Yes, typically the equipment we are using in the lab are the same that we use inside the industrial processes because we try to fit with the requirements. We try to have the less variability so that what we do in the lab is the same at what we will have into the industrial processes. The main difference will be about the sampling part. So for example, I can talk about the spectroscopy. So to do spectroscopy, we implement probes inside the process or in the lab, and the probe that we can use inside the lab can be different from the one that we use into the industrial processes. But the technology is the same, it's just the sampling part, so how to implement it inside the industrial process.
If I understand, this kind of analyzers generates a lot of data because we talk about chromatography, we talk about spectrophotometry. So that means each measurement is a spectrum or a chromatogram. Mm-hmm. What are the characteristics of this data that you are handling from online analyzer?
We consider this kind of data as complex data. We do the differentiation between sensors and complex analyzer. So usually when we talk about sensor, is one information that is given from the sensor. So it can be a viscosity, a pH, a temperature, any kind of sensor. And when we talk about complex analyzer, such as spectroscopy or chromatography, this is a lot of information that are given. So if we do some comparison, it can be like you implement 1,000 of sensors inside your plant, but all those information are gathered inside one analyzer. And those information are correlated. So you have a big matrix that is generated and that contains a lot of information about the process. So it can be either chemical information, bio information, or physical information, depending on which analyzer you use and what information you want to get.
How can industrials effectively use the data from this analyzer to fulfill their requirements? Because you mentioned it's a complex data, but industrials, they have a very specific challenges they want to solve. So how do we make the bridge between these two aspects?
So this is a big challenge for us to do so, because depending on what the industrial wants from the analyzer, we will think about how to manage the data. You have to know that you have a lot of information from the analyzer, but only a few part is used from the industrial. For example, when they want to have any kind of property, let's say a concentration for safety reason or for some quality product, they use a model of prediction to predict those properties. So you have also another way to do this, what we call a non-supervised analysis, data treatment. And so in this kind of way, you just monitor the global aspect of the process and you don't go into details by predicting some properties. And so the idea is also to do some combination between the data from the analyzer and the data from the sensor. So this is why this is also a critical part to do data fusion. And so, for example, this is why we do a lot of work with Optimistic to facilitate this kind of data fusion, which can be quite complex because you have different sources of data.
In order to be more practical and in the explanation for the people listening, could you go through 2 or 3 use cases that you develop for industrial application so we can understand better what you do?
Yes, of course. So usually we have some industrial that come to us with some problematic. So they have, typically, we can have an example into the polymer field. They have one problematic, they do offline measurement, so they take one sample and then they do the offline analysis. So this can be quite a long time to do so. They can have the result many hours after they have taken the sample. And so the idea for us is to take those samples in our lab to test different technologies. So more and more, the spectroscopy is the technology that is used because this is simpler to implement compared to the chromatography. And you also have short time of response. You can have information every second or every minute, depending on the technology. So this can be quite interesting to monitor well the process. And so in one of the case of application, the idea was to monitor the concentration of one product for some safety reason. Because if the product is at a concentration that is at a level higher than the safety requirements, it means that you have some explosion risk or any kind of risk that can be quite challenging and quite dangerous for the operator or even for the process unit itself. And so the idea is to have a fast response within the minute, for example, so that you can have a fast correction that can be applied so that you can be inside a safe condition. And in this case, we have a good result with the spectroscopy. And so this technique was implemented online so that they have a safety protocol to manage those concentration which is at risk.
Manis, you explained how you help industrials implementing online analyzers. Do you go up to the training of operators? Because for them, it must be a big change in the way they manage their production.
Thank you for this good question, Mathieu. So for the operators, they have their own way to pilot the process. And so this can be quite challenging to change their habits so that they can implement industrial analyzer. Because this can be quite complex analyzer that we have seen. And the idea is to let them know what information they can get from this analyzer, that they are not fully responsible for the analyzer, that you need some person in charge of those analyzer, and that can help them to better run the process and to better pilot the process. So that if they have any issue or they want any way to run the system properly, they get this information in real time and they can have some intervention directly. This can be really time-saving, and also they will work into better safety condition because they do not need to go every time in contact with the product or anything, but they will only do some intervention on the pilot when it is necessary.
In order to summarize all that, suppose I need to gather real-time information from the product involved in my process. How can I proceed with Axel'One analysis?
So the first step is to contact us, of course. And after that, we'll try to discuss to understand your process, what can be done, what you are doing at the moment, so that we can try to find the best solution, and if any solution can exist, so that we can fit your requirements. So it can be either response time, it can be some quality criteria, it can be also some safety reason. So we'll consider every aspect, so that we can manage your need. So as I said before, the idea is to first do some experiment at the lab to understand the product that you have, to understand which technology can fit the best with what you want to do. And after that, we'll try to do in some upscaling. So we have some pilot inside Axel'One that we can use to replicate the reaction or the process if necessary. So we can go into industrial site to do it at a small scale first. And then we can go into a bigger scale so that we can do it into the process production directly.
Thank you, Manis, for sharing your valuable experience with us today.
Thank you, Mathieu, for the invitation, and feel free to contact us.